In this video, I am going to show how to express such a composite fraction in partial fractions. The difference between this type of fraction and the ones that I've dealt with in previous videos is that this one is not a proper fraction. Let's show why we say this is not proper. If you check the degree of the numerator, the highest power of x in the numerator is 2. So the degree of the numerator is 2, but the degree of the denominator is also 2. This is not proper in the sense that in algebra, fractions are proper if the degree of the numerator is smaller than the degree of the denominator, which is not the case in this case. So this is not proper. How do we deal with such a situation? We perform what we call long division. Let's divide x squared minus 3x plus 2 into 2x squared minus 3x. When we divide like that using long division, we divide this term x squared into 2x squared, just this first term into the first term. That gives us 2, because that x squared will go leaving us with 2 here. Then we multiply this 2 by the whole of this expression to create 3 expressions, terms here. 2 by that is 2x squared minus 6x plus 4. We then put this in brackets and subtract the entire expression from the one above, term by term. Here you can assume that there is 0 there. So 2x squared minus 2x squared will give you 0. Negative 3x, subtract negative 6x. This negative and that one will become positive. So we end up with negative 3x plus 6x, which is a positive 3x. But 0 minus 4 is a negative 4. So this is the remainder and this is the quotient. That means this fraction here can now be written as 2, this whole number, plus 3x minus 4 all over x squared minus 3x plus 2. So at least now, this part is a proper fraction in the sense that the degree of the numerator is 1 because that exponent there is 1. But the degree of the denominator is 2 because this exponent there is 2. So the degree of the numerator is now less than the degree of the denominator, which means this qualifies to be a proper fraction. So we can now proceed in the normal way of factorizing the denominator, then we express that into partial fractions. So this entire fraction, which I may call f for reference purposes, I don't want to rewrite that. The fraction is equal to 2 plus 3x minus 4 over, if I factorize this, I will have x minus 1 brackets x minus 2. By inspection, these are the factors of that. Now, this is now equal to 2 plus, now this one can now be expressed as a over x minus 1 plus b over x minus 2. So you can now proceed. Check my previous videos how I dealt with obtaining the value of a and b. Then you get those values, and that is the process of expressing that into partial fractions. If you are not able to continue from there, let me know in this comment section, but please refer to the previous videos. From here, I've dealt with cases like this. Thank you so much.